So today we're going to be talking about the law of sines, and then I don't know, we'll have to see how long it takes. We might have to pause it, and we're going to go on and have a second part where we're talking about the area of triangles. Before I do that, I wanted to actually show you something that we've been covering. I know it's hard to see this, and the reason it's hard is I actually have a copy here of a problem that was from an ACT question, like in an ACT book. So you can teachers can go and request, can you have the book when you're done with them, after you've given the test, and I think this was in April of 2012. So I just wanted to talk about it. It says an airplane taking off from an airport climbs at a constant angle of ascent, so it will reach an altitude of 10,000 feet. When the airplane has flown 8 miles, as illustrated in the figure below, which of the following expression gives the angle of ascent? So we have our angle here. So we're talking about this angle right here. That's our angle of ascent that we're wanting. This here would be our opposite, and that's 10,000. And then our 8 miles, and to get miles into feet, we would multiply 8 by 5,280, and we'd have our feet. That is our hypotenuse. So we're dealing with hypotenuse, and we're dealing with opposite. So I'm thinking we're going to be dealing with sine. So we're talking about sine. Well, look what we see here. All right, so we know that the sine of the angle that we are talking about would equal that opposite side, 10,000, divided by our adjacent side, which would be, or hypotenuse, excuse me, 5,280 times 8. Well, how do we find sine? Usually what we do is we write this word sine inverse, and then we would put this 10,000 over 8 times 5,280. Well, they don't have the sine inverse, but they have what we found is the exact same thing, arcsine, as sine inverse, all right? So knowing all of that information would tell us, hey, the answer there is C. So it is important to know, first of all, that arcsine is the same thing as sine inverse, and how to do all of this math information. All right, so today we're going to really focus on, first, how do we use the law of sines to find the measure of a side of a non-right triangle. So big thing you need to know about law of sines. We are no longer in right triangles, all right? So it's temporary, all right? But law of sines is not for right triangles. It's much easier to use trig functions for right triangles. It is for non-right triangles, so not for right triangles. It would work in a right triangle, but there's easier ways in a right triangle, okay? So our rule, and you'll find this is on your yellow sheet, and you're going to want to write this down, that A over the sine of A equals B over the sine of B equals C over the sine of C. The ratio of the side length to the sine of the opposite angle is equal for all sides and opposite angles. Now let me make sure I make a note this, that I would be just as right if I wrote here the sine of A over side A equals the sine of B over side B equals the sine of C over sine C. It doesn't matter what's on top. And so actually you're going to see it both ways depending on which book you see it with. I think our book is this way, but I can't even tell you for sure. I might go back and forth. You might see me use one time one way and I think of it another way a different time. It's okay as long as you keep the ratios and the same in all of the fractions that you're dealing with. So in all the fractions, the sides either have to be all in the denominator or all in the numerator. So I wanted to make that mention. So let's look at an example. We're solving a triangle. If you remember, solving a triangle means we're going to find all the side lengths and all the angle measures. So that's important to note that we're going to solve it. What we have here, because we don't have a right angle, it does not matter what is L, what is M, and what is N. It makes sense to me to make M the obtuse angle here because they tell us that the measure of angle M is 112. So visually, this one looks right, but honestly, it doesn't matter, okay? What we need, our list of, okay, what's our to-do list? What we need to find to solve this triangle? We need to find, oh, I got to write in here. We had L, I missed L was 22. We need to find 3 things. We need to find the measure of angle N. We don't have that. We need to find the length of side M, and we need to find the length of side N. Okay, 3 things. I think the easiest to find, first of all, is that measure of angle N. We are going to use the angle sum theorem. All right, that angle sum theorem, I'm going to use THM for theorem, tells us that all angles in any triangle always add up to 180 degrees. I call it the 180 rule. So what I'm going to do is I'm going to take 180, I'm going to take away 29, I'm going to take away 112, and I'm going to get 39. All right, so my missing angle here, sorry about that, is 39 degrees. Now, I need to go and say, what is my side M here? How do I find this side M? Well, I have a couple options. I think my best option is to look here at this L, my angle L. I could have used angle L. Oh, no, excuse me. It's best to use angle L because angle L is across from the side 22. All right. So I'm going to use that ratio. So I'm going to say 22 is the side length across from the angle of 29. So I'm going to say over sine of 29. That equals, I'm missing, let's start with M. M, side M, over the sine of that angle M, 112. So what I need to do now is I need to do cross multiplication. So if you remember your rules, when you have a fraction equal to a fraction, you can take the one diagonal, multiply the two, and it equals the other diagonal multiplied together. So in other words, here, M times sine of 29 equals 22 times sine of 112. Okay? So now I just need to divide both sides by sine of 29. So I'm going to just divide both sides by the sine of 29 here. And I'm going to get that M. So now my problem is I just have to take 22 times the sine of 112 and divide it by the sine of 29. Now that equals 42.07. I'm going to just say 42.1. Okay? So we found here our M to be 42.1. My last problem is, what is my N? A lot of you, and I've seen some students say this, Pythagorean theorem, and they get really excited and they say, oh, we have just a missing side. We don't have a right angle, all right? So we don't have a right triangle, so Pythagorean theorem doesn't hold. We're going to continue to use this law of sines that we've used before. So let's go ahead and do that. I'm going to see if I can find some space over here. We're going to use law of sines again over here. So again, I'm going to say the ratio of 22 to the sine of 29, that's now going to be equal to the ratio of that side N to the sine of angle N, which is 39 degrees. And let me show you here how that's 39 degrees up there. I know it's hard to see. We kind of have to have space. Again, we're going to do cross multiplication, and N in the end is going to equal 22 times the sine of 39 divided by the sine of 29. And for that, I got that N is equal to 28.6. All right, I hope I'm right on these. I don't have the best calculator that I'm working, but I think I'm right. All right, so we've solved our triangle. We found the three missing spots that we were working toward. All right, let's see if we can go. Trying to decide. Let me look here something in a second. Yeah, let's do one more example. All right. One more example here. I'm going to have to kind of really find some spots for this. All right. So one more example. Let's see if I can cut this. Just one second. There we go. So here we go. All right. Just give us some space here. All right, so now our problem is we have an ABC triangle. I'm going to make this A, this B, and this C. So for our picture, it doesn't matter. It helps to have the obtuse angle be the angle that looks obtuse. It helps to have the one that looks to be 35 degrees, 35 degrees. And then if side B is 37.9, right here would be 37.9. Okay, so we're missing now three things. And it's always going to be three things that we're looking for when they say solve a triangle. In this case, what we're missing is we're missing the measure of angle C. All right, we have the measure of angle at A and B. We're missing the length of side C and the length of side A. And it's in no particular order. We don't have to solve it in this order. Although again, just like the last problem that we had, The most easy one to solve for is going to be the measure of that side C. So all we need to do is we need to take 180, we need to subtract 105, and we need to subtract 33. When we do that, I got 44 degrees for my answer. Okay, so I just used the 180 rule to find the measure of angle C. Now we're going to go for side, well, it doesn't really matter, side A, let's start with. It doesn't matter what we look at first. So for this one, I'm going to say, okay, my side, 37.9, in ratio to the sine of the angle across from it, 105 degrees, equals the side A that I'm looking for that's in ratio with a sine of 33 degrees, okay? Again, we're looking at doing cross multiplication here. So my A is going to equal 37.9 times the sine of 33, and then I'm going to divide that by the sine of 105. So when I do that on my calculator, I get, so A equals 21.4. Now I have to figure out what B is. So I have 21.4 here. I have to figure out, excuse me, side C. So again, we're going to use that same idea that the ratio of 37.9 over the sine of the angle across from it should equal side, now we're talking about side C over angle C, all right? And angle C, if you remember, we calculated it, is 44 degrees. So it's sine of 44 degrees. Okay, so my C is equal to these two multiplied together, and we divide by this one. So we're going to have 37.9 times the sine of 44 divided by the sine of 105. C equals, and that equaled 27.3. So that was our last answer. All right, so the homework that I want you guys to work on today is page 316, just 5 and 6, and then 11 through 15. Not too many problems.